Hi everybody, I'm in school today and I've got the two slit interference pattern thing experiment, as well as this is what we call the diffraction grating. So what I'm going to do is I'm just going to shine this red laser through two slits and you can see the pattern that's formed on the whiteboard. Okay, and then we're going to compare it with what you see in a diffraction grating. So here you go. So that's a pattern formed. I hope you can make that out. Okay. Now, as compared to that, now this diffraction grating here, if you look at it, so each of these things is about a centimeter long, and the first one, it says, can you see 100 lines per millimeter? So a millimeter is only a tenth of this. So in a tenth of this, in 1 millimeter, there are 100 gaps. So in a whole centimeter, there's 1,000 gaps. And this one has got 300 lines per millimeter, and the last one's got 600 lines per millimeter. So this is just a piece of glass through which they have used a tool to cut all these gaps. So instead of 2 gaps, you've got a whole lot of them. And that's what a diffraction grating is. So what happens when we pass a red laser through a diffraction grating? So if I stand here, hope you can see, that's what you get, okay? And then further apart, and this is your 600 lines. So when it's 600 lines per meter, the more number of lines you have, the further away they are, okay? And then if I move closer to the whiteboard, watch what happens. If I move closer, the gaps become closer together, okay? If I move further away, they get further away. So if you can see the difference between a diffraction grating and two slits, can you see the light, the fringes as they're called, are bright, they're well defined, and they're widely spaced. And the thing is, because there are so many gaps, there's a whole lot of them have to come together to form your antinodal lines or the bright spots. So there's a lot of destructive interference happening, and then when they do come to interfere constructively, you get them very bright and sharp and well defined. So, but we can use the same formula as we do with the two slits for a diffraction grating. The only thing is the only formula that we can use with the diffraction grating is n lambda is d sine theta. We cannot use the abbreviation formula, which is n lambda is dx over L. We cannot use that because, can you see the x, the fringes are very widely spaced, even though I'm not that far away from it. So there's not a whole lot of difference between x and L. So this formula doesn't apply. We can only use the top one, which is n lambda is d sine theta. So I hope that was useful, and I'll do one more demonstration with what happens when, instead of laser light, now laser is what we call monochromatic light. It's light of a single frequency. So this was red laser, but instead of red light, what happens when I use white light, which consists of a whole lot of colors, and that's quite a spectacular thing. So this is it for now.